Hello and welcome. My name is Ahmad Khan. I am a cybersecurity researcher. And today's lecture we're going to talk about DLL injection, what DLL injection is, how it's gonna work, and how we can code our own crafted malicious DLL in order to inject into any target running process to take fully control in any system. So first, let me give you an idea of DLL injection, what I mean by DLL injection. Here you can see here, let's assume that our target process is notepad.exe. We want to target this process, I mean notepad.exe. It will be anything, it will be cal.exe, it will be, depends on you, whatever you want to target you can. But in this particular lecture, I'm going to give you example of notepad.exe. Notepad.exe, let's assume that this is our target process. We want to target this process and we want to inject our malicious crafted DLL into this particular process. Once we will do this step, the process will load our malicious DLL in order to gain fully control on any system. So let's assume that this is our running process, which is basically notepad.exe. What we have to do, we have to create an empty buffer inside this process. This will be extra memory location for our DLL. But what we have to do, instead of placing DLL in empty buffer, this empty buffer will hold the part to DLL, because DLL is P file and it should be parsed during loading, during runtime. So the DLL will be in our file system. What this buffer will does, it will hold the part to our DLL that exists on our file system. So then what we have to do, once we create an empty buffer, once this buffer will hold the part to the malicious DLL that exists in our file system, we will use load library using kernel32.dll in order to achieve this particular task. So once we load this library, how we can do this, as I said before, we will code practically. I will show, but this is just I'm giving an idea. So once we will use load library using kernel32, DLL will be placed inside target process. Once the DLL will place inside target process, of course this DLL is malicious and it's crafted, so it will load our malicious code. Once it will load our malicious code, we will be able to take fully controlling the system. We will use the shell code. Shell code is just basically shell code is just basically machine instruction to achieve any particular task. Usually shell code are used for exploits, malware, etc. But of course this is exploit development course. You can say like not course, it's just a topic about exploit development. Again, I'm going to repeat. We will first of all target any process. Once we target our process, we will create empty buffer inside our target process. This empty buffer will hold the path to the DLL. Of course, we need a memory location, which will be our empty buffer. Once we will create empty buffer, so this empty buffer initially will hold path to DLL. The DLL will be in our file system, and the next step we will use load library using kernel32 in order to load this DLL. As I said before, why empty buffer should hold the path of our malicious DLL. Of course, DLL is a PE file, portable executable file, that need to be parsed during runtime. So this all process is called DLL injection. We are injecting DLL. I mean the DLL will be crafted DLL into a running process. So let's get started. First of all, we will code DLL, and then we will try to code inject. We will try to code injector or DLL injector as well. That will help us to inject DLL. I mean that will help us to achieve this particular task. So I will move to my Windows operating system. So I have open code block. I will click on create new project. Of course this is DLL. So I will choose dynamic link library. I have to click on go. I have to click on next. So the project title will be like first of all, yeah, destination. Okay, so it will be DLL, or it will be crafted DLL. So I will click on next, and then I will click on finished. So it's done. I will click on sources. I will click on main. First of all, I'm going to write some codes, then I will explain the code line by line why I'm doing this. First, of course, I have to include some necessary library. First library will be hash include stdio.h. This library will be for input and output. The second library will be like hash include windows.h. Of course, we are dealing with Win API to load DLL, etc. So it will be windows.h, and the third library will be like hash include. It will be stdlib. Of course, we are dealing with memory management in order to allocate extra memory, so that's why we will include stdlib.h. And third one will be last one will be hash include string.h. Of course, we are going to deal with shell code, and it's okay. So now what we have to do, first of all, we have to declare an array of byte named payload, which will contain shell code. Shell code, as I said before, shell code is typically a sequence of machine instruction used for various purposes, including exploit and malware. So what I have to do, I have to declare unsigned character array. So it will be unsigned char. The array name will be payload. So I will use this, and inside this array we will place our shell code. So the shell code I have already in this, you can see here. So I have to copy the shell code, and then what I have to do, I have to paste here. So we're done. Now we are okay with the shell code. This line declare an array of byte named payload which contains shell code. So now what we have to do, right now we have to store the length in bytes of the shell code. So for this purpose, again, I will use, of course, our array is unsigned, so I will use unsigned unsigned integer payload, and then I will payload, it will be length. Of course, we are specifying the length, so I will specify the length. Okay, so now what does it mean? Sorry, I forget command terminator. This variable basically store the length and byte of the shell code containing the payload array. In this case, the shell code is 276 bytes long. Now what we have to do, we have to define another function by using extern. Why I'm doing this? First, let me implement, and then I will explain it to you. So I will use extern __. It will be deck. This function I will use for DLL export. So I will use DLL. So it will be DLL export. So I will do this for go function. It will be go, and I will specify the type. It means that white. This line declares a function named go with __ deck l space, and it takes parameter DLL export attribute. This attribute indicates the function can be accessed from outside the DLL. The purpose of this function is to execute the shell code. Okay, basically the go function, now what I have to do, I have to implement the go function. That will inside a go function we will declare several variables, but first of all, as I said before, let me implement it, and then I'm going to explain it. What does it mean? So I will implement the go function. It's white type. So now what I have to do, I have to declare some variable. Then I will explain one by one why I'm doing this. So it will be like mem, and then I will declare bool variable, and then what I have to do, I have to create a handler variable for threads, and then I will create double word, and it will be old protect. Initially the value will be 0. So I'm explaining this. What does it mean? The go function begins by declaring several variables including exec, mem, rv, th, and old protect. So exec mem function is for memory location. Of course, we have to locate memory. rv function is for storing return value. Not function, I'm so sorry, variable. Th variable is for thread handling, and old protection protect variable is for storing the old memory protection setting. Okay, so now what I have to do, I have to allocate some memory. I will explain. First let me implement it, then I will explain to you what does it mean. So I will call the variable by name, and I will use virtual alloc function, and then first argument will be like 0, second will be payload length, of course, and third will be mem underscore comment, and then I will use pipe, and then what I have to do, I have to call mem reserve function, mem reserve, and then I have to call page read write. What does it mean? Let me explain it to you. What does it mean? Here the code allocate a region of the memory in the process using virtual alloc function. The size of the allocated memory is determined by payload length basically, and it is both committed and reserve. The memory is initially set to read and writable, of course, by using page read and write function. This is necessary. We have to read and write the memory in order to allocate memory source. Now what I have to do, I have to call in the function RTL. Why I'm calling this function I will explain to you in a bit. Just let me implement it first. I will call this function. Again, it will take some argument. So the first one will be exec mem, the second one will be payload, and then it will be payload length. Okay, so what does it mean? Let me explain it to you. This line copy basically the shell code from the payload array to the allocated memory. Basically exec underscore mem is the allocated memory using the RTL move memory function. This effectively places the shell code into the allocated memory. Okay, now what I have to do, right now I have to deal with the virtual protection. So first let me implement the code, then I will explain it to you. rv equal, it will be, I will call a function virtual protect. Again, it will take some argument. First one will be exec mem, second one will be payload length, and third one will be page underscore execute underscore read, and last one will be, basically I will use dereference operator. It will be point old protect in order to dereference the point. So what does it mean? Let me explain it to you, the code. Okay, so the code then changed the memory protection, allocated memory. I mean, the code, this line of code will change the memory protection of the allocated memory. It set the memory to be executable by using the function page execute read. Okay, while storing the previous protection setting and alt protect, we have to use a condition. If the operation is success, it proceed. Okay, so for this, what I have to do, I have to use a condition. If rv not equal to 0, we have to proceed something. What we have to proceed, we have to proceed with threads. So I will call the variable thread. I will create a thread, I have called this function, and again it will take some parameter argument. It will be 00. I'm going to explain it why 00, etc, etc. So I will call lp thread start routine function, and then what I have to do, I have to call variable execmem, and then again 0 0 0. Okay, so let me explain it to you. This line of code create a new thread by using function create thread to execute the shell code. Specify the starting address of the thread is exec memory. Okay, effectively instructing the thread to start executing the shell code. Now we have to implement another line of code that will wait for the thread to finish its execute using like it will use wait for single object. So we have to call it. So what I have to do, I have to call the function wait for single object, and it will take thread, it will wait for thread, and the second one be 0. And then what I have to do, outside of if statement, I have to return 0. So that's fine. Now what we have to do, we have to create another global function outside of the main function. Okay, I will create a boolean function, and then I will explain that the type will be, the function nature will be boolean that will return true or false. Why I'm doing this, first let me implement it and then I will explain it to you in a bit. So bool, I will call when API, when API, and then I will call DLL main. Okay, it will take some parameter. It will be instance inst DLL, and another will be dword, which is basically double word, fwd reason. Okay, and lp void I will call this, and then lp resort. Okay, lp okay, so I will explain this to you in a bit. So basically in this line of code, DLL main function, a special function that is automatically called when a DLL is loaded or unloaded by a pass. It receives information about the DLL load and unloading event. And the DLL, right now what I have to do, I have to implement something by using switch case. So for this purpose, I have to use switch, and I have to check multiple conditions, cases so I will call this, and this inside switch I will use cases. Case 1 will be DLL underscore process attach. If this true, we have to call goal function, and then we have to bracket. Okay, now come to the second case. We have to check DLL thread attach. Okay, if this is so, we have to bracket, we don't need it. So and another case will be DLL underscore process detach. If this is so, we have to break it, and outside of this we have to return true. It will be true. So DLL main, as I said before, is a special function that is automatically called when the DLL is loaded or unloaded by a process. It includes, you can see here, it includes a switch case statement that handles different cases depending of the FWD reason parameter. Okay, and this code, when the DLL is loaded into the process, DLL process attach case basically the go function is called to execute the shell code if this is true, DLL process attach. This code essentially loads the DLL into a process, and when the DLL is loaded, execute the shell code contained with the payload array. The shell code execute occur in a separate thread, and after the execution is completed, the thread is waited for before the go function return. Okay, so now this is the code for DLL. So now we have to save it, and let's see if we are getting an error or not. Okay, we are getting an error. Let me point out there we are getting expected primary expression before th create thread. Let me check it why this is happening, and then let me try to fix it. Okay, RV virtual and okay, we have inside f th create thread 00 will be thread start routine. Okay, I'm so sorry. Now let me execute it again. Okay, the code is fine. So now let me check it if the DLL is created or not. So if I will open it, I will go to ban debug. Okay, our DLL is created. So I have to cut it, and I have to move to the main file, folder. So I will paste here. I will delete it. Now we will try to code injector. So I will close it. I will try again. Okay, I will use code block again. Of course, right now we are going to create DLL injector that will help us to inject DLL into file. So for this purpose, of course, I'm going to use C. I'm waiting for the code block as it will open. Then we will try to code DLL injector. So right now you can see here I will click on create new project, and it will be application console application. I will click on go. Next, it will be C. Project will be injector DLL. So I'll click on next. Okay, it's done. So I will click on main. So of course, first I have to include some library. Hash include. It will be, of course, we are dealing with Windows APIs and DLL, so I have to include when Windows library, and then we have to include string as well. Hash include string.h hash include TL help 32. So here we now what we have to do, we have to define a function. We have to begin by defining a function name target, something like this. The function will take a process name as an input and attempt to find the process ID of the target process with a name. It will initialize variable and structure for process information. So let's start with it. So it will be integer function. The name of the function will be find target, it will take some parameter. Parameter will be process name. Okay, so proc name. Inside this function, what I have to implement? I have to implement a code that will find for current process ID. So I will create a handle variable. It will be hproc snap. Okay, and next one will be process entry 32 will be p32. Okay, and initially I will create a variable and the value will be 0 for the process ID. This variable will store process ID, of course. So now what I have to do, let me implement some more line of code, and then I will explain to you why I'm doing this, why I am implementing, what does it mean. So I will call the variable hproc snap, and I will call a function create tool help 32 snapshot. This function will help me to create snapshot of the current process, and this will take some parameter. First one will be th32 cs underscore snap process. So this one here we got, and second one will be 0. So then we will check a condition. If invalid underscore handle value we got here equal hproc snap, then what we have to do, we have to return 0. So now let me explain this code for you people. Basically here we begin by defining a function name find target. This function takes process name proc name as an input in attempt to find the process ID of the target process with the name, initialized variable, and structure per process information. Okay, now move to this code. This code create a snapshot of the current running processes using create tool help 32 snap. Okay, if creating the snap false, of course, if it is invalid, the function will return 0. So now what I have to do, now let me call p32 dot desize function method, equal, I will equal this size to the size of what, to the size of process into 32. Okay, and then I will check if not L, what I have to do, I'm so sorry, I have to check if not process 32 first. I think this is, yeah, we have to call this function, and here it will take the snap and the p32 file. Okay, if this is so, then what we have to do, we have to close the handle. Of course we will not be able to find it. Okay, we have to call, we are closing the function for what, for proc snap, and then it will return 0. So now let me explain this code to you. This line of code set the DW size, basically DW size field of PE32 structure to the size of the structure and native information about the first process and the snapshot. If the enumeration of process fields it closes, okay, here we are going to close by calling the function close handle, the snapshot handle, and return 0. Now what we have to do, we have to implement loop that will iterate or the process. So what I have to do, I have to use while loop, while process 32 next, I have to search for next. This will take for hproc snef int pe32. So if this is so, what we have to do, we have to check if lstr lstrcmp, we have to compare this, we have to call this function, and it will take proc name and pe32.czexe file. Okay, if this is equal to 0, then what we have to do, we have to store process id and pid. Okay, of course we will be able to get the process id. It will be like pe32.th, and it will be okay th process id. Okay, and then we have to bracket. Now let me explain too. The loop iterate through the processes and the snapshot and compare the process name. Okay, if a matching process name is found, it store the PID in the PID function, variable. Okay, and break out of the loop. So finally what we have to do, outside of the loop, we have to close the snapshot handle and return the PID of the target system. Of course, this function will return the target PID. So I have to call close handle, and I have to close hproc snef, and we have to return PID. Okay, that's completed. Now what we have to implement in the main function, we have to declare some variable to hold handles, pointer, etc. etc. So I have to implement main function initMain. In the main function, I have to provide some parameter because it will take some time. So it will be argc and then it will be char argv and array. So inside this function I have to declare some variable. First it will be handle p handle. Okay, then it will be p void ram buffer. Okay, and then we have to, as I said before and as I told you in the starting of the lecture, we have to load library, we have to call. So how we can do this? First of all, I have to use a function p thread underscore start underscore routine, and it will load p load library equal, I will equal this to null. Okay, and then what I have to do, I have to declare character byte array that will hold the path to the DLL that I have, and then next one will be target. Okay, so the target is, of course, target will be notepad.exe. Okay, so it's done, and PID will be equal to 0. So in the main function, we declare variable to hold handles pointer in the name of the DLL to inject in the target process. The PID variable is initialized to 0. Okay, so then what I have to do, I will call the instant to the function name is find target, and I will pass an argument to the find target function. The argument will be target. Okay, of course we are going to find PID for our target process. Okay, so now we have to check if PID equal 0. What we have to do, we have to print something. Printf, it will be target not found. Okay, and I will return -1. If the condition is false, if the condition becomes false, then what we have to do, we have to print, of course, we will have the target PID. So I will call I will display a text target PID, and it will be %d. I will display the PID. Okay, so then what you do, it print the PID of the target process and proceed to retrieve. Okay, so now what I have to do, I have to call pload library, and I will equal this to pthread start routine. Okay, and then what I have to do, I have to use get proc address function, and then it will take get module handle this one. Okay, this module will use kernel kernel 32.dll. okay, and then it will use load library A. Okay, so then what I have to do, I have to call p handle, and this will store I will call open process function. Okay, this function will take some parameters, argument. First one will be process underscore all underscore essays, it will be double word, and then PID. Now let me explain this code to you. This will retrieve the address to the load a function library from the kernel target to DLL. I mean this line of code. Okay, using get proc address. Okay, this function is used to load the DLL into the target process. Now what we have to do, we have to use a condition to check if the process handle is successfully obtained. Then it will allocate memory within the target process, and it will write the DLL part to that allocated memory, and will prepare to load the DLL into the target process. So now we implement it. So I will check a condition if p handle not equal null, then what I have to do, I have to call rem buff, because we have to create empty buffer, and this buffer will hold virtual allocated memory for the p handle, and then null size of DLL. Okay, and I will call again mem underscore comment is we did, and the DLL coding page underscore read write, and then I have to write process memory. So this function will take handle argument rem buff and lp void DLL and size of DLL, then null. Okay, so as I said before, this conditional statement checks if the process handle is successfully obtained. It means that it will allocate memory within the target process by using virtual allocate function. Okay, now what we have to do, we have to create remote thread within the target process that call load library A with the path of the injected DLL. It will also print the address of the allocated remote buffer and close the process handle. So let's implement it. So I will create, of course, to create remote thread, I will call create remote thread function, and this function will take, of course, p handle and then null 0 p load library and p load library rem buff 0 null. What we have to do, we have to print a message done address, and then we have to display the address. Okay, I will call string formatting, I will use so rem, I will call rem buffer. Okay, and I have to print out address, and once I print the address, then I will close the handle by calling this function. I'm going to close it for h handle, of course. So once I do it, I'm sorry, I have to do this inside conditional statement, if statement. Okay, so outside of this statement, what I have to do in else part, I have to print if process field. Of course, there will be some error if this is not true. Okay, and I will return -2, and the main function finally will return 0. So it is done. So now what we have to do, this is the injector code. I have to execute it and let's see if it is okay. Okay, we are getting an error. Sorry for the spelling mistake, it's const. So now again let me execute it. We are again getting an error, process 32 okay. Now let me check it where the error occurring basically. So here if lstmia proc name and pe.scexe file equal 0, so pe equal to PID equal to pe.th32. It's so sorry, th32 process ID. Yeah, so now let me execute it again. Okay, now we are getting an error here. So too many argument for virtual function. Okay, so we are getting an error with the virtual function rem buff equal virtual allocate alloc x. It's not alloc, it's x. Let me execute it again. Okay, it's return. I'm so sorry for all these mistakes. Now it's done. You can see here it's done. We got it. So if I will visit this, I have to cut and I have to paste here, and then I have to delete this one. Okay, close it. Yeah, oops. One mistake. I will point out the mistake. If I will open the code, we didn't specify the path of the DLL, so I have to click and choose. Let me open code block again. We didn't specify the path of the DLL, and then I will open the project with the code block in order to specify, and then I will try to, let me delete it. I will try to rebuild it. So I will open existing project, so it's DLL injection. Okay, yeah, of course I think this one. Here you can see here we have to specify the path for the DLL. So what I have to do, I have to copy the path for the DLL. You have to put extra backslash, and here again, and the file name is, I have to press Ctrl A, Ctrl C, and then I have to specify. Now it's done, I will do it. Okay, it's done. Now what I have to do, I have to visit Ben debug, and I have to cut, I have to paste here. Now if I will open Notepad, you can see here. So if I'll open DLL, inject DLL.exe, let's see what's happening. And you can see here calculator is successfully opened. I just opened Notepad, calculator is open. So this is how DLL injection works. I hope you will enjoy this lecture. Please share this lecture with your friends if they are interested in this topic. Thank you.